Well, welcome everybody. Thanks for coming to this month's edition of Pizza and Programming. Today we are going to be talking about containerizing jobs on the cluster with a new tool called Singularity. That's like in the last 6 to 8 months really taken off and gotten extremely popular in high performance computing environments. Before I do that, I just want to kind of talk very briefly about what's new at ACCRE and introduce a couple of new features that might be useful to users in general. Who in here uses Vanderbilt Box? Okay, who in here has never heard of Vanderbilt Box? That amazes me. Okay, so Vanderbilt Box is like Dropbox for Vanderbilt. All right, so if you go to, I think the URL is, let's see here, vanderbilt.account.box.com. Anyone who works at Vanderbilt or students at Vanderbilt automatically have, I think, 25 or 30 gigabytes of space on Box. And it's almost identical to Dropbox in terms of the functionality. It makes data sharing extremely easy. And we recently had a user ask if it was possible to sort of synchronize your data that's stored on Vanderbilt Box with data on the cluster and vice versa. And the answer is yes. So Box actually has a very robust API, which makes it relatively straightforward to do things like this. And so if you go to our GitHub repository called user-misk for miscellaneous, so these are like miscellaneous tools that don't really fit neatly into any of our other repositories. There is a directory called mirror directory from Box. And it's essentially just a bash script, and you can open it up. It's pretty straightforward what it's doing. It's running it's using a tool called LFTP to talk to Box and to synchronize directories that you have on Box onto the cluster. And it's pretty trivial to go the other way. So this script demonstrates how to go from Box to the cluster, but it's just as easy to push stuff from the cluster to Box if you like. So if you're a Box user and you find yourself constantly copying files down to your local machine and then SCPing them up to the cluster, there's a much easier way. And so this script will kind of get you started along that path. Other announcements that we have are that we will be upgrading. We're kind of in the process of upgrading the operating system from CentOS 6 to CentOS 7. We are admittedly a little bit behind. We had hoped to be actively pushing compute resources over to CentOS 7 this month, but we've hit a handful of snags that have made that a little more complicated. But luckily, we're not really working on, we're not aware of any deadlines that are sort of constraining our date. So we're sort of taking our time and being methodical about it to make sure that we get it right and minimize impact to users as much as possible. But that is coming. It'll be in the next month or two, I would say, when we really start transitioning compute hardware over to this new environment. And the biggest impact that will have on users is that software will have to be rebuilt. So if you have a piece of software that was built and installed in our current cluster environment, chances are it's no longer going to be able to run within the CentOS 7 environment. So if you're using tools from set packages or LMOD, it shouldn't be a big deal because all that software will still be available and rebuilt in the new environment. But if you have stuff like tools compiled and built and installed in your home directory or your Scratch directory or something like that, those are going to need to be rebuilt and reinstalled. So that's just something to be aware of. Yeah.
And if you're still using set packages, transition to LMOD.
Yeah.
While set packages is still available.
Yeah.
Because once we move, if you're not aware of that, once we move to CentOS 7, set packages will not be available.
Right.
All the software will be supported only through LMOD.
Right.
So in order to avoid, on day 0, oh my God, the thing doesn't work anymore, start transitioning right now.
Yeah.
Okay?
So for those of you online that didn't hear that, it would behoove you to begin using LMOD right away. That way you know how to use it once the CentOS 6 cluster goes away. Because set packages and PKG info are no longer going to be available in the new environment. And if you want to learn how to use LMOD, there's documentation on our websites. There's a video on our YouTube channel So there's lots of ways to learn it. It's relatively straightforward to learn, and we really love it, and we think you guys will too. Okay, is there any other announcements you guys can think of? Okay, great. So I will go ahead and move into today's topic, which again is on singularity. So I was just joking with Bill, if you're a physicist, you probably get really excited hearing a name like Singularity. So it's not really related to that type of singularity. I don't know if the developers were maybe physicists or what, yeah, let's get started. So I want to start by first just introducing in general the notion or the idea of virtualization. And so historically, kind of the first way that virtualization was, I shouldn't say that, but one of the first ways that virtualization was accomplished was through something called a virtual machine or a VM. And so the idea with the VM is that you use software to emulate an entire computer. And when I say entire, I mean not only the software and operating system, but actually the hardware as well. So you have virtual CPU cores, you have virtual RAM, you have virtual hard disk space, a virtual network, and so on. And within a virtual machine, you actually end up carving off some portion of your host computer's resources to dedicate to that virtual machine. So let's say you have a scenario where your personal laptop is running Windows 10. Okay, so that's what we would call the host. But you have a piece of software that only runs within Linux and will not run within Windows. This is actually not a very uncommon experience at all. Well, one approach would be to spin up a virtual machine or a VM and to install a tool like, or an operating system like Ubuntu Linux, which is probably the most widely used flavor of Linux today, and to dedicate some of the host resources, maybe a core and a couple gigabytes of RAM, to that virtual machine, and then run your software from within that VM. All right. So in that way, you don't have to go out and buy a brand new computer. You don't have to dual boot. And so that's another approach, is you can actually have two operating systems installed on your computer, and when you're booting your machine, you can say, okay, boot into Windows or boot into Linux. There's some trade-offs there, and it kind of depends on what you're wanting to do. But in general, the advantage of the VM is that you can run it from within your Windows, in this case, your Windows environment, and it's much easier to spin up the VM and to get started and get going. If you want to have basically all of the resources available to you for your software, then that would probably mean that you want to dual boot instead of create a VM. But don't want to spend a lot of time talking about those trade-offs. There are a lot of free tools available for spinning up VMs. Probably two of the most popular free ones are VirtualBox and Vagrant. VMware is another very popular one, but it's not free. Although I don't know if there's a free version. I'm actually not sure. But the tool I use on my laptop is VirtualBox. It's extremely easy to install and to set up. And so let's say I'm, in this case, running a OS X from my Mac. But if I wanted to, I could easily, and I already done this, install or spin up an Ubuntu VM from my Mac. And so VirtualBox will give you this nice graphical interface where you can manage all your VMs from. And in this case, you would create a new VM, and I've already done this, so I won't go through the entire process. But if you click on Settings and go to Storage, essentially you would want to upload like a virtual disk here, which would be an image of the operating system that you're wanting to install. And so Ubuntu is free, like all versions of Linux, it's free. And if you go to Google and you just type Ubuntu 16 image, the very first hit will be Ubuntu 16.04.2 LTS, which stands for long-term support. If you click on that link, then you have a couple of links. Probably 100% of the cases, all your machines nowadays are going to be 64-bit. And this is a nice desktop version, which will give you the graphical interface. So you would just click that link, and depending on how fast your network connection is, you'll wait anywhere from a minute to maybe 10 minutes for that to actually download. And then once you have it on your local machine, you can upload it here within VirtualBox and then come back and you just double click it and away you go. So the first time you do that, you'll actually be taken through the operating system installation process. So you'll have to install the operating system like you would be on bare metal, like on your laptop or on your computer without a virtualized service like VirtualBox. But in my case, I've already gone through that process, so this is just going to boot up, and eventually we will see a very Ubuntu-like interface pop up, and there we go. So now I have a Linux virtual machine running from my Mac. You can do things like share a clipboard between your virtual machine and your host machine to easily copy and paste back and forth if you like. VirtualBox is in general a more graphical approach, whereas I haven't used Vagrant a lot, so for anyone who has, you can correct me here if I'm wrong, but I think Vagrant's more of a command line based, like command line centric virtualization like interface. So if you're doing a lot of provisioning and you need to automate that process, it probably makes sense to use Vagrant instead of VirtualBox. All right. So the advantages of a VM are the following. The first big one is the ability to do testing and development outside of a production context. Okay, so it's just good practice as you're developing a tool to test it heavily, to make sure that it's going to work and nothing's going to break when you actually deploy that to a production environment. I know this is like a research environment where development and production often get used together and kind of mixed and matched. And so you might not quite appreciate the value of this, but especially when you're thinking of traditional software development, having some sort of sandbox that's completely isolated from the rest of your production environment provides a ton of advantages. And in this case, you can do it without, again, dual booting or buying a completely new computer that's dedicated to just running that environment. Another big one that I've already kind of mentioned is overcoming software portability issues. So if you have a tool that can only run within Windows, but you're running a Mac, Mac Parallels, I think is what it's called. I've never actually used it, but I think it provides basically a Windows VM that you can run from your Mac. You can do the same thing with VirtualBox. You can also stack multiple VMs or multiple computer systems on a single bare metal computer. So it's not as though I'm limited to just having a single VM. I can have 5 or 10 or a dozen depending on the resources available on the host. Consolidation and isolation of applications and services running on a single server is also a big advantage. So if you have multiple applications you want to run, especially in scenarios where they share dependencies, it might make sense to completely isolate those in their own environment so that when you update one dependency, it doesn't break another tool and things like that. Another nice thing about VMs is that recovery of the VMs is very, very simple. Once you've gotten to a certain state that you're happy with, you literally just with a click of a button can capture that state. And if you end up breaking that VM later, it's very easy to recover. And then the last one, sysadmins in the house will appreciate this, decreased hardware maintenance. Okay, so that's a VM. The next step is containers. And so you can think of a container as similar to a VM, but it has the following important differences. The biggest one is that it emulates just an operating system and not the entire system of underlying hardware. So it's no longer kind of carving off the host's resources. It will just use those resources directly, and you don't really have to tell it, you don't have to limit it to a certain number of CPUs or RAM and things like that. It also, importantly, in the context of Linux especially, shares the underlying kernel of the host operating system. So within a VM, that is not the case. The virtual machine actually gets its own kernel that it talks to the hardware through. It also, a big advantage of containers is that it requires fewer resources. So generally, it's considered more lightweight than a virtual machine, meaning it requires less CPU cycles, less disk space, less RAM. And so you generally can stack a lot more containers on a single bare metal system than you could virtual machines. And also boot and deployment times are much faster within containers. Anyone heard of Docker? Even if you've used it or not used it? Okay, fair number of people. So Docker is by far the most widely used containerization tool in use today. And it is, it allows Linux containers to be created that are isolated from the rest of the system. It uses an image-based deployment model. It allows access to the host root file system, so all of your files that are stored on your host you can easily see and access from your Docker container. And so, Docker has become a huge player, I would say, in combination with web services like AWS in the last 3 to 5 years. So software development companies make huge use of that combination. So if you have access to AWS and you have a service or an application that you want to make sure is up and running, well, you can sort of containerize that or Dockerize that a single time. And then once you have that image, you can easily pass it around and deploy it as many times as you want within AWS or elsewhere. Basically anywhere where Docker is installed. One tiny hitch, though, of Docker is that by default, users can gain root access to a host root file system from inside a Docker container, which is horrible news if you are managing a high-performance computing cluster where you have hundreds and perhaps thousands of user accounts and sensitive data that you have to protect. And so for that reason, Docker within a HPC context it's just a non-starter. And that's been one of the most frequent questions we've been asked in the last 2 or 3 years. When are you going to start supporting Docker? Well, it's not quite that easy. But luckily, the folks at LPL, what's that stand for? Livermore. Lawrence Berkeley, thank you. They're at Lawrence Berkeley, have developed this awesome tool called Singularity, which we'll be talking about today. And you can think about Singularity as a container providing service, much like Docker, with the only difference being that your permissions inside the container have to be identical to your permissions outside the container. So that means if you cannot become root access on the cluster, you cannot become root from within your container running in the cluster. And this is exactly what we need, and it helps kind of fulfill the requirements of a shared HPC resource like the one that we manage. And so it allows users to access their files that are stored outside the container, much like Docker would do. So that's a big deal. It means that you don't have to manually copy files from your home directory or your scratch directory to your container once you deploy it. You can CD into it, copy files around from it, just like you would from a Docker container. It's designed with performance in mind for HPC applications. And so this is something we're currently doing. We're working specifically with Bennett Landman's group right now. And there are some potential concerns when you're trying to read from the same image, let's say 300 or 400 times at once, that we're still working through. But in general, performance when you're using a container versus running the same application outside the container should be very, very similar. They've dedicated a lot of time and effort to that. It also supports conversion of Docker images to Singularity images. So I know a number of you sounded like you were already familiar with Docker and maybe already using Docker. So if you already have a container that's running like on your laptop and you do everything from there, with a single command, you can easily convert that Docker image to a Singularity image, which can then be run on the cluster. And so in terms of standardizing your workflows, Singularity makes that much, much easier, and that's a huge benefit. And finally, it's installed on the cluster. So before getting into this, let me briefly touch on a little bit of terminology, which can be confusing. And I thought I had this completely figured out, and then I read through the most recent version of Singularity's docs, and now they're being inconsistent with their usage of these two terms. But this is certainly, I think, consistent with the Docker terminology. So an image is just a file that includes a virtual file system and software installed onto that file system. And so your image is generally what you're passing around and you're using to launch a container. So like an instance of a running image, we would call a container. And so an image you typically build a single time and then deploy or run multiple times. And then finally, an image is immutable, meaning it cannot change. Once you have your image, it's static. There are ways with Singularity that you can go in and install. You can sort of modify an image, but that's really bad practice because it hampers reproducibility, which is one of the biggest reasons you use Singularity in the first case. Okay, so a very typical workflow would be that you have a personal Linux machine, which could be a virtual machine, where you create and bootstrap an image. You then copy that image to the cluster, and then once it's in your /home or /scratch directory, you can deploy it as many times you want. And in general, you make it generic enough that, so if you're running like a Python application, but you have different kind of variations of a Python script that you want to run through the Python interpreter, you would have a single version of that image, and it's generic enough that it can handle that. And it could read in different types of Python files and so on. All right, so I'm going to go over 3 main workflows that you could utilize when running Singularity on the cluster. The first one is the most time-consuming, but it's also not super hard, as you'll see. I'll walk through a pretty simple example, and then it's a little bit different in that it requires you to actually have root access to a Linux box. So that's sometimes the most difficult part. But if that is an issue, again, it's very easy to install a tool like VirtualBox on your machine, and then to install a Linux OS there where you can install Singularity and build your image. So yeah, let's focus on this first workflow first. So this is the build it yourself approach. So here you need sort of 2 separate environments. You have your, as denoted with this dashed blue box, you have your personal Linux box where you have root access. And so the first step is to install Singularity onto that virtual machine, or if you're lucky enough to like have a desktop in your lab where you have root access, that works too. So in my case, I've already installed Singularity onto this VM, and I won't spend time going through how to do that. That's documented on the Singularity website, and it's like 4 commands. It's pretty foolproof. There's not a lot of dependencies at play that you need to worry about. And so from here, just to convince you that Singularity is indeed installed, I'll just run a which Singularity. All right, and so you've got Singularity, which is the main command, and then Singularity supports a number of subcommands like run and exec and test and shell, which we'll discuss as we keep going here. So on my VM, I have root access, and that's allowed me to install Singularity. And step 1 is to create an image. And so generally you do this just by creating a blank image where you specify the size. There's a default size of like 728 megabytes, and if you need more space than that, then it's trivial to just pass an argument where you can make a larger image. And the actual creation of the image, you don't need to have root access for that step, so there's no sudo needed. But for the next step, which is bootstrapping the image, you do need root access. And the reason for that is that during the bootstrap, that's generally when you're installing software, and you need to have root access inside the container in order to install that software. So therefore, you have to run that Singularity command with sudo. And so once you've bootstrapped your image, you then, the last step is copying it to the cluster and then using that image to launch your container or any number of containers. And then obviously within that shared environment, you do not have root access. And in fact, it doesn't have to be limited to the ACCRE cluster. If you're using other like federal resources, I think more and more of those are installing Singularity as well. So again, that's another huge advantage. It doesn't matter if the operating system at that cluster is different than the one at ours. If you have everything in a Singularity image and both sites have Singularity installed, then that saves you a lot of time and effort having to rebuild your software. Okay, so let's actually start talking about these commands. And so the first command is a Singularity create. And so within all these examples, I'm going to be using an Ubuntu 16 example. So that just means that my image is going to be running Ubuntu version, major version 16. And this first step just creates a blank image with a virtual file system. And it's got a default image size of 768. And I wrote there that it requires root privileges to run, but that is incorrect. I just got done telling you it wasn't. So that should say not. I apologize for that. And then in the bottom, you see an example of a command of a Singularity create command where we're now passing additional options for creating a larger image. And so if you know that you're going to be installing a bunch of dependencies and a bunch of libraries that take up a lot of space, then you'll need to expand that default size to something like, I don't know, 2 gigabytes or 5 gigabytes, depending on how much space you need. There's also this handy force option. So if the image already exists and it already has a size, but you want to resize it, instead of removing it and recreating it, you can use a force option to just expand the size of the image. One thing about Singularity to note is that it's currently only supported on Linux platforms, which is the reason you need to have it installed in a virtual machine. All right, so bootstrapping is probably the most involved process of creating your image. And so again, the bootstrap has to be done with sudo. So you have to have root access where you're running this. You could not run this command on the ACCRE cluster. You could run it, but it would fail. And so within your bootstrap file, or your definition file or spec file, you'll see it called a couple of different things. You define a recipe, much like a Docker file if you've used Docker, that's specifying the OS you want to install, the software you want to install, any environment variables that you need to set up, and things of that nature. In the most recent versions of Singularity, they've transitioned to calling this definition file Singularity with a capital S. And so that very last argument that I'm passing in that top command is just that definition file. That was not the case in 2.2, but in 2.3, they've decided to make that the convention. So let's see. A definition file essentially contains a header and multiple sections. And so within the header, this is going to be the very top of your Singularity definition file, you're going to tell Singularity what operating system you want to install and where you want to pull that image from. So in this case, and there's lots of different options here, I'm giving it a bootstrap :docker, which means I'm actually going to pull that image from Docker Hub. Docker Hub's a website that contains a bunch of different Docker images. And in this case, it has the latest version of Ubuntu that I'm going to pull down from Docker Hub. And then after that, I have a number of different sections. And so this is a complete Singularity definition file that we'll be walking through today. This header we've already seen. We're telling Singularity we want the latest version of Ubuntu. This next section is called the run script section. And so the run script section is essentially the default kind of mode for your container. So generally when you're building a container, you have a single application in mind that you want to run in a very specific way. This run script section is where you define that. All right, so in this case, we're using exec Python 3 double quote $ ampersand double quote. Can anyone tell me what that means? Any Linux pros? What's that? Is it all the command line? Yeah, right. So that just means take all of my command line arguments from my Linux command line and pass those to the Python 3 interpreter. And so that's a very common thing to see within a run script section, and it provides a lot more flexibility. For instance, if you want to run different types of Python scripts through this container, you can pass the name of the script from that command line, and in this case, it would execute Python 3, myfile.py from within the container. And I'll show you exactly how you run that in one of the next few slides. The next section is your post section, and this is probably the section you will spend the most time on, depending on what you're needing to do. And so the post section is just run a single time from within the container as root. And it's where all of your setup and software installation steps need to go. All right? And so if you're going to be running these on the ACCRE cluster, probably something you just want to get in the habit of doing every time is the following line. And what this will do will enable you to access all of your ACCRE storage. And so /home, if you're launching your Singularity container from your home directory, will be available by default. But if you want access to your scratch space, or if your group has /data space or access to doors, you'll want to include these lines. And you'll also want to make sure to include these GPFS lines as well, because /scratch and /data are actually symlinks to those directories. So that's just something that, yeah, it's good. It's in the process of going away, but it's not quite gone. The next thing to do is to actually install your software. And so in this case, again, I'm using Ubuntu, and Debian flavors of Linux use a package manager tool called apt, or apt-get. And so apt-get-y update will basically update all of app's repository information so that I'm getting the latest versions of all the libraries that are managed and installed by apt-get. So I'm running that first from my post section, and then I'm going to do an apt-get-y install, and then the following package names. And so here I'm just installing Python 3, NumPy, a tool called nose, which allows me to run the NumPy unit tests. And then I'm going to go ahead and just install the GCC compiler and everyone's favorite text editor, Vim. So that's the post section. And this is a pretty simple example. This section can get a lot lengthier depending on what you're needing to install. But if you're going to be building things by hand, like doing a configure, make install, for example, that would be done from within here. A few rules of thumb. You always just want to install to default system directories. So you don't want to do things like install to a home directory from within your image. Just let the software install where it wants to install. The typical place is like user local, and that's completely fine. Okay, so that's the post section. And the final section is a test section to verify that everything within your container is working as expected. So in this case, I'm going to run the NumPy unit tests. So I'm doing an import NumPy as np:\np.test. And so that's again using nose to run through a series of NumPy tests, just to verify that NumPy is actually functioning correctly. And so the test section by default will be run at the very end of the bootstrap process, but you can also run it manually after you've already created your image. So you could do something like a Singularity test image name, and it will run this section for you. A few other notes. All these sections they support just standard bash syntax, so you can think of them as bash scripts. All right, so let's actually walk through how you would go about doing this. So here I've got let's try to make this a little larger. Okay, so here I've got my Singularity definition file within my virtual machine. And I'm going to, I already have an image called Ubuntu 16.mg, which was built using this spec file. But I'm going to go ahead and build it again, just to walk through the process. So I'm going to do Singularity create new image. Let's call it my image.img. All right. So there we see myimage.img with the default size that I talked about. And now if I want to actually bootstrap that and install some software, I do a sudo singularity bootstrap your image name followed by your definition file. All right, and I'm going to let that run. The post section will, in this case, will actually run fairly quickly. The tests will take a little while, so I'm going to scroll back over to my slides, and then we'll check back on that in a few minutes.
Excuse me, Will.
Yeah.
Is it using your Ubuntu 16 image that was in that directory, or is something else happening?
So you mean this image right here?
Yeah.
No, it's not touching that at all. So I had made that previously, and I've already copied it up to the cluster, so we don't have to wait a few minutes for the SCP to complete. So it's not really touching that at all. I created a brand new blank image and then I'm bootstrapping that image, which means just setting it up and installing all the necessary software to it. And I just called it new myimage.img.
Was it the first two lines that told you that this was going to be an Ubuntu, the Docker line and the Ubuntu line?
Yeah, exactly. So right here, these two lines. And there's different ways, there's different methods of bootstrap, and you don't have to pull from Docker Hub. There's actually Singularity Hub. You can pull from there if you want. And so I won't spend a lot of time going over all the different options there, but if you go out to the Singularity docs, it'll kind of walk you through the different options for the header section. All right, so it's still installing. There are a handful of other sections that you can define within your definition file that I didn't include in this first simple example. Files is one. So essentially, if you need to copy a file from outside the container to inside, you would define it in this files section. Labels is basically gives you the ability to assign attributes to your Singularity container or image, I should say. So that's not really doing anything for from a software standpoint. It's just assigning labels. Like I might assign labels of Python 3 and NumPy in this case if I wanted to. The setup section is one that you will see occasionally. In the setup section, commands are performed once outside the container prior to the post section running. All right, so there are some kind of limited scenarios where you actually need that. One being if your post section needs files that live outside of your container, you can copy them in from your setup section before moving on to your post section. And then the final section is an environment one, and this is where you would define things like environment variables that you want to exist within your running container. All right, so all of the NumPy tests are still running. Looking pretty good so far. And since I'm talking about Ubuntu, and Ubuntu is in general probably going to be the most popular operating system environment from within your container, since we use CentOS, which is a Red Hat based Linux variant. I would expect most people to lean towards Ubuntu. And if you're not familiar with kind of trade-offs between those two environments, the biggest one that's often highlighted is Ubuntu tends to be a little more bleeding edge. So they emphasize more recent versions of packages, whereas Red Hat and CentOS emphasize stability. And so for that reason, CentOS 6 is currently on like the 2.3 kernel or something like that, which is really, really old. And Ubuntu is on a much more recent kernel. So that's kind of the trade-off you run into. And in general, I know within research that people prefer the bleeding edge and more recent versions of tools. And so for that reason, I would in general recommend using Ubuntu within your container. And so if you're going to be using Ubuntu, you should be familiar with the package manager, apt-get. And so these are probably the most frequent commands you would use. I've already talked about apt-get install. You can pass this --y option. Otherwise, it will ask you, are you sure? And you have to answer yes and hit enter, which is super annoying. apt-cache search keyword if you want to search to see what packages with a certain string are available within its repository. apt-get update will download all the most recent versions of the repositories of the packages that you want within its repository. And so, like when you initially install your operating system, things will be a little bit out of date, and so you always want to run an apt-get update before you start installing stuff. apt-get upgrade will upgrade the versions of packages that you already have installed. apt-get dist upgrade is a slightly more intelligent version that is supposed to handle complex dependency issues a little more intelligently. All right, so that's just a brief rundown of apt-get. All right, awesome. And so it looks like my test ran successfully. Ran 5,790 tests in just under 2 minutes. 7 failed with a known fail error, which is fine, and 15 were skipped, which is also fine. So we can be pretty confident now that NumPy is set up correctly and it's running as it should. And so from here, you have your myimage.img that what you would want to do is copy this up to the cluster if that's where you want to run it. So I'm just going to use SCP to do that.
You could run it inside your virtual environment.
Correct. Yep. I could just as easily run it from here. And that's probably a good kind of rule of thumb to make sure that things are working as you expect. You can actually shell into your container. So that might be the first thing I would do, is actually shell into it and kind of poke around and making sure that things are working as you expect. But for now, let's give that another half minute to upload. And in the meantime, we'll talk about how you actually run your container. So once you have your container, you can use a command called Singularity run, which is going to run that run script section that you've already defined. And so that, if you recall, we had this run script section with Python 3, and we're passing all of our command line args to the Python 3 interpreter. You do not need root privilege to run this command. So that means you can run it from the cluster, you can run it on your VM, you can run it anywhere Singularity is installed. So if I wanted to use this on the cluster, I could do something like module load GCC in Singularity, which is using lmod, and then running Singularity run image name followed by the Python script. And this will get passed into our run script section, and it will run Python 3. It'll use the Python 3 interpreter to run this script. So okay, the image has been uploaded, and so I'm going to come over here to my Mac terminal, and I should see, yes, there's my image. So myimage.img, and so I'm going to do a module load GCC Singularity, and now I should be able to do a Singularity run myimage.img, and then I have a Python script called bmark.py that I'm going to run that through. And that should take a few seconds to run. There we go. So it took about 8 seconds to run. And if you want to actually look at this file, it's not really doing anything exciting. It's just doing a simple dot product of two matrices here, or two vectors, I guess. And so it took about just under about 8.5 seconds to run. And you can, again, you can run this from anywhere where Singularity is installed. Let's see, did I miss anything? And in general, it's good practice to find your most common workflow through a run script section. Just that aids reproducibility. If you're wanting to make this as reproducible as possible, the thing you're going to be doing most often should probably go in your run script section. There is also a subcommand called exec, which allows you to basically run any generic command from within your container. All right, so if I wanted to run, let's see, I still need to provide my image name, and I can do something like Python 3 version. So it prints the version of Python 3 that's installed within that container. If I do that outside the container, I get a different version. So it's picking up the correct version from within my container. You can also do things like, again, you can actually run that command through the exec subcommand if we didn't have this defined already in our run script section. If you want to run more than a single command, then you can just throw those commands into a bash script and then pass that bash script to the exec subcommand. So the exec subcommand provides a lot of flexibility. In general, though, the run subcommand is preferred, again, for reproducibility. The final subcommand you can use is used for shelling in to your actual container. So if I did a Singularity shell, myimage.img, then there we go. So now if I do like something like this, whoops, then I see that indeed it thinks the operating system I'm running on is Ubuntu 16.04, whereas from outside the container, it should give me information about CentOS. So outside the container, I'm running a completely different operating system from the one inside the container. The shell subcommand also supports a writable option. So if you want to run this as root from your virtual machine or your personal Linux box, you can do that and then fiddle around with installing software. So sometimes the first thing I'll do is I'll actually do that. I'll do a Singularity shell writable just to get things up and running. And then once I've developed the commands that I need, then I'll go back and put those in my post section to automate it. But in general, you don't want to get in the habit of using that writable flag. That's kind of a hacky way that's not documented well. There's no history of it. And again, it defeats the purpose of reproducibility. All right, so I'm going to speed through these last two. They're not nearly as long. Using an existing image, the advantage of this is that you don't need to have your own personal Linux box with root access. So you can just pull, if there's an image that already exists on Docker Hub or on Singularity Hub and you just want to use that exact image, then you can just pull it down directly using a few commands that I'll talk about in the next slide, and then run that container from your image.
So if somebody has already built a container and put it up that has the software you want to use,
Exactly.
you can just grab that.
Exactly. Yeah, if they've already installed NumPy and Python 3 into a container using Ubuntu 16. Whatever, then yeah, it makes sense just to go ahead and pull that and use that directly rather than reinventing the wheel.
Build their software and put it in a Docker image somewhere, and you want to use their software.
If it's a Docker image?
Yes.
Yeah, so there's a way to convert Docker images as well. That's the last one I'll talk about. But if you're just pulling an existing image directly down, there's a number of ways to do it. The most straightforward is just this last one, a Singularity pull, followed by Docker : / and something like Ubuntu latest. Docker Hub has, again, a huge number of images. If you log into their website, you can explore those and find one that's most appropriate. But you can also do it through a two-step. If you want to create the blank image first and then use Singularity import, that also works just as well. For converting your Docker image, all that's needed here is a personal machine with Docker installed, and then your shared Linux environment like the ACCRE cluster. So you would run something like this, some variation of this monstrosity of a command shown here in the middle of the slide, like docker run -v. And the important pieces are this is the path that you want to write the resulting Singularity image to. And this is the name of the image on Docker Hub that you want to convert. But you can just as easily do this with a Docker image that already exists on your personal machine. You can test a container. Like I said, this happens by default during the bootstrap process. But if you want, you can also just do a Singularity test myimage.img, and it will run those unit tests again. You do not need root privilege to run this. You can also sniff an image. So if you want to inspect the various sections that were used within a definition file, you can easily do that. So I'm going to just do that for my VM. Singularity inspect my image.img will return something like that. And then I can include options here, like if I only want to see my test section, like show me the exact test that you're running, you can include that. You can also look at the run script section, which is often very convenient. Sometimes it's very easy to forget, and rather than going out and looking at your definition file, you can just run that command instead. There's also a Singularity export command, so if you're going to be sharing your image with collaborators, you might want to compress it slightly. And so this export subcommand will allow you to create a tarball. You can also pipe that to a tool like gzip to make it even smaller. All right, so what are good use cases for Singularity? Like, why would you actually want to adopt this new random piece of software? One big reason is that you need a newer or different version of a library or piece of software that is not currently installed on the cluster. One classic example that we've seen a lot with TensorFlow is glibc. CentOS 6 uses a very old version of glibc that's not supported by a TensorFlow. And so instead, you can actually install TensorFlow into an image, to a Singularity image, and run that on the ACCRE cluster. Or you might have, a super old piece of software from a publication that came out 5 years ago, and you're trying to reproduce it, and it's using like old 32-bit libraries and stuff that you have no business using on the cluster. Well, if you want, you can solve that by running it within a container, and then you have complete control over what gets installed. Another huge reason would be if you want to decouple your workflow from software available in the cluster. So you'd basically be, if your pipeline depends on a number of different tools that are installed on the cluster or even in your home directory, you would be reducing the number of dependencies down from N to just a single dependency, which is Singularity, which we're going to work hard to make sure is up to date, installed, and available for everyone to use. And so that would greatly reduce the impact of any OS or software or library updates that occur on the cluster. A perfect example is the CentOS 7 upgrade, which will be coming in the next few months. So if you package up your workflow right now within a Singularity container and get it running, as soon as there is a CentOS 7 environment available, you're good to go. You already have that image packaged up, and you can deploy it just as easily from the new environment. Another big reason would be that you want to standardize your workflow across lots of different platforms. So if you're running, on a supercomputer at a national lab, but you also run stuff on your lab computer, and you also run on the ACCRE cluster, they all have different operating systems, different versions of libraries. It's a huge headache and huge hassle to manage all that. It would be much easier if you just had a single image where you package it up and you can deploy that anywhere where Singularity is installed. Another reason might just be that you hate Red Hat and CentOS and you want to run stuff from Ubuntu all the time. Okay, fair enough. Go for it. You can just install or you can build your own Ubuntu image with all your preferred tools and run everything from there. There's probably other reasons that I'm not thinking of, and so if people have other ideas, feel free to shout them out.
Well, if you want to try a piece of software, you can go, typically going forward, developers will be building images.
Yeah.
So that's going to be the future of software deployment. So if somebody has a cutting edge piece of software they've written, they'll put an image up on Singularity. You want to try it out, it's just not right.
Yeah, that's a great point. That's a great point. So this is only, virtualization and containerization has exploded in the last 3 or 4 years, and it's definitely not going anywhere. It's here to stay, and the environment's only going to get more robust. Only more developers are going to begin working in it. So it, again, behooves you to learn this tool early so that you can actually leverage the work that other people can be doing for you. Any others? Okay, I'm going to hustle. So you might also be asking yourself, okay, I've got lots of different options here. I can use stuff that's available through LMOD. I can install tools myself in my home directory or Scratch directory, or I could install all this stuff into a Singularity image. Which approach is best? Is there a one-size-fits-all? Does it make more sense in certain situations to use one method versus another? So I've kind of outlined some rules of thumb here, and these are by no means etched in stone. So if folks have some other ideas, again, please feel free to offer those. But I would say I would definitely use LMOD in cases where you need fast results and the version is already available for you. Maybe your workflow is not super sensitive to certain software versions, and that you don't have very many dependencies to worry about. It would also make sense to probably stick with LMOD if you're using like accelerated versions of software, something like MPI or multi-threaded or GPU apps. It's possible to get those up and running within a container, but it takes a little more effort and it can be a little more painful. Another great example would be commercial software. So if you're running MATLAB or Stata or using the Intel compiler, then you're not going to be able to do that from within a container. Finally, when to install software locally. The best time to do that would be, again, if the software is not available through LMOD, if you need your results very quickly, and if you have relatively few dependencies to worry about, so that when those dependencies are updated, your tool is not broken. And then finally, I would strongly encourage the use of Singularity due to all the reasons that I've already discussed on the previous slide. But in a nutshell, if you really want stability and reliability within your workflow processing, and you want to standardize all of your analysis into a single simple image, a single bundle, then I would, again, strongly suggest Singularity. It's awesome for that. There's great, awesome documentation for Singularity available at the following URL. It is possible, as I mentioned, to wrap up MPI or GPU-based jobs in the Singularity cluster. Josh has written a really nice, or sort of adapted, a really nice definition file that we've stuck on our GitHub repository if you want to get like a GPU-enabled app running within a container. Containerization, I've already talked about all this. It provides a number of benefits, some of the biggest being that it decouples your application from the software that we have installed. You can have a standard multi-platform workflow, and there's no performance penalty. We have already started putting a few custom images at /scratch/Singularity, which are world readable. So if you want to start playing around with those, feel free. And then we also have created a Singularity GitHub repo where we have some documentation and instructions for running those. So if you're interested in looking through that, please feel free. Yeah, thanks everyone for coming, and I'm happy to take any questions if you have any. Any questions? Yeah.
I'm sorry if this is maybe a boneheaded question, but if my workflow is usually submitting an array of 100 or 1,000 jobs, would I submit 1,000 Singularity images? Or would I select one and then do the slurm inside that?
Yeah, that's a good question, and that's something we're still trying to work through. Because if you have 1,000 jobs that are all hitting the same image at the exact same time, which is all stored on GPFS, then we've had one group report that there are issues with startup times being really slow. So we're still trying to work through that and troubleshoot that to see if there are things that we can do, if we can configure things or tweak things differently to make it run better. If it comes to it, we might have to image users. We hope it doesn't come to this, but we could potentially manage users' images from /temp space on compute nodes to avoid issues like that. So we're exploring a few different options.
Yeah, but in either case, it's always you submit from the cluster a bunch of jobs, and within the job you start the Singularity image, but not vice versa.
So within Singularity, you would never do an S batch?
No.
Okay.
And in fact, you wouldn't be able to because you can't see. We don't have the paths where Slurm commands are installed, mounted to, binded to the actual container. Anything else?
When I create the GPFS 22 in my container, that is bound when I start my Singularity image?
Yeah, so /home will, assuming that you are launching the container from your home directory, will by default be there. So you don't have to do anything in your post section to get that directory bind mounted. But if you want to use files that are stored in Scratch or /data or doors, then you would. Anything else? Okay, well there's lots of leftover pizza down here, so feel free to come grab a piece, and thank you all for coming.